So I'll be talking about common sense, which is a hard thing to talk about, but I'll try. I'm Božidar. My vanity slide, I shortened it significantly since last time. There's my blog, there's my Twitter handle. I tweet a lot in Bulgarian, so probably if you're not Bulgarian, you wouldn't like to follow me. And I'm currently a senior software engineer at TomTom. Working from home, but that doesn't matter. Speaking of software development, it's a maze of technologies, of processes, of everything that you can do and you cannot do. We have TDD and BDD, we have domain-driven design and design-driven development. The latter, I don't know what it is, I just found it under the DDD acronym. We have SOA microservices and a bunch of other ways to structure our code. We have a bunch of external systems like MQs, ESBs, rules engines, data processing engines, and whatnot. And our task is to select what to use, what not to use, what to apply, what not to apply. But software is still crap. We have all these technologies, all these processes, and it's still bad software. I mean, yeah, we write sort of okay software. Software is also fine. But if you look at another person's software, I'm sure that you can find ways that you can say, okay, that's crap. And we soothe ourselves by saying that, well, writing software is hard. And it is. I mean, we wouldn't be getting these salaries if it was easy. Here are some real methodologies that are used in the wild. The hype-driven development, especially famous in startups, where you just gather a bunch of technologies and you put big data, put the cloud, put Node.js, put whatever you don't understand, and then you have software that probably doesn't work. In big companies, there's also demo-driven development, which includes writing software just for the demo, because that software would never be shipped anyway. There's also the copy-paste driven development, which is more for newbies and junior developers that just find some piece of code on Stack Overflow and copy-paste it into their code base, and maybe it works for a while. And my favorite is the denial-driven development, which is kind of the not invented here syndrome, in other words, but we'll talk about that later. So what is common sense? Common sense gives you less bugs, maintainability, extensibility, scalability, eternal life, hunger in Africa eradicated, etc. Applying common sense. Now that's hard, because there's no definition of that. Its definition is itself, and that makes it hard to define. What I will do today is I'll try to define it with counterexamples. We'll see if that works. So the first counterexample of, yeah, let's make an API. Okay, and let's make an API and then never write against it. And even not write against it while we're designing it. And the result of that is, for example, these lines of code, which you may guess is transforming an XML document to string. When you design an XML API, you would say, okay, I want this file to be loaded in memory as a string. No, you cannot do that with the standard APIs. You have to have a transformer factory, then you instantiate a new transformer, configure it with some strange properties, then create a writer, use adapters because patterns are cool. There's DOM source, there's stream result, and then do the string. And then you get the document. There's no easier way with that API. And that's an API that someone has designed, and he hasn't taken into account the default use cases that the API would be used for. So yeah, we wrap that, we make a nice static utility XML utils, and we put that code there, so we already have it. But the designer of the API didn't do that. And it's very likely that someone will do this piece wrong, even though it's the most upvoted on Stack Overflow, for example. So when designing an API, a lot of people don't think of the actual use cases that the API will be used for. They just write something that handles the business logic they have, who will be using it, how they will be using it. Doesn't matter. There are constructors with temper parameters, which obviously you cannot remember. There are different order of parameter pairs, like weight, height, width, height, etc. In some method there one order in the other method there, the other order, yeah, it's hard to use these APIs. So yeah, we probably should write against them while we are writing them. Speaking of APIs, let's do another thing. Let's use raw JDBC. It's very easy to set up. Yeah, that's the main pro for JDBC. And then we will probably end up eventually building something that resembles an ORM that is very buggy because we have built it ourselves, and that maps our relational structure to our objects, which, because we are using Java or an object-oriented language, we will need this transformation anyway. The reason that people decide, okay, let's drop ORMs and let's use JDBC is probably because they're using ORMs wrong. Now, ORMs have a sin that they are hiding, and unfortunately, they're not being attacked for the right reasons. The right reason to attack an ORM is that it's very hard to set up properly, and it's very easy to shoot yourself in the foot with it. You can have a lot of leaking stuff. You can build you can fetch entire database into memory without even knowing that. So ORMs, their sin is they make it easy to shoot yourself in the foot, but that's something you can overcome by knowing what to do with the ORM, not by using raw JDBC. Again, speaking of APIs, let's use Java util date. I haven't seen a project for the past, I don't know, 10 years that doesn't have Java util date somewhere in the code. And it's horrible, and we know it. We have JOTA-time, we have java.time for a while now, since Java 8. And still, at least in some parts of the application, we use Java util date. Or it creeps in from other libraries. That is an excuse, at least. Why it's bad? Well, it is mutable, it is not time zone aware, it has a broken API, it has a deprecated API. And generally, I think if I ask that whether everyone agrees that Java util date is bad, everyone will agree. And yet, it's there. And because sometimes it's there because we have to take some extra steps in order to use it with, for example, Hibernate or JSON XML serialization. Like, you have to write an adapter or a custom writer or something like that. And these things exist, actually. They're already written. You just have to import a Maven module for that. Maybe it won't work with the latest version, so you have to tweak something. But it's not that hard. And it spares you from having to manually convert from Java util date to the JOTA-time, for example, date time. And still, yeah, we use a broken API every day. The next sort of generalization of the previous slide is let's homegrow a framework. I fortunately haven't worked in a company where someone said that, but I know people that have. So everything that is not invented here, that is not written in this company, we don't use it. So we boycott it, we ignore it, we just make our own. Like, for example, an ORM. Because Hibernate is bad, it has bugs, we have to write our own. We have, I know people that have written their own web frameworks because, for example, JSF is bad, Spring MVC is bad, Wicket is bad, and so they write their own. Well, it sounds kind of obvious that something that is out there and being used by hundreds of people would be less buggy and more stable than the thing that you would grow, even you're a very good developer. But that's something that probably someone sometimes forgets. And yeah, what could go wrong if we homegrow a framework? Maybe waste 6 months. I don't know. The management probably even doesn't know that we're homegrowing a framework. They would kill us if they knew. What we can do instead, of course, is extend or patch existing frameworks if they don't do exactly as we want them to do, which happens, of course. Frameworks are not suited for every single use case that we can have, so we can extend them, we can patch them, we can plug our code in them. Sometimes it's easy, sometimes we have to use reflection, but even using reflection to plug something into a framework is better than writing your own. I think that's kind of obvious. And let's not use the latest versions of software that we have available. Today, Vasil spoke about Java 8, but it's too new. I've heard that. They say, well, Java 8 is too new. It probably is buggy. I don't know. And latest Spring may have bugs that they have still not discovered them because it's too new. Another thing, we don't have time to learn the new things. Java 8 has lambdas. Who would spend time learning lambdas? We have software to write. Well, also we don't have a standard infrastructure for that. For example, we have a Nexus where we have our approved versions of the dependencies deployed, and something new takes a lot of time to approve. So yeah, let's stick to Java 5, which is already out of date, or Spring 2. And yeah, I think that the best approach to this thing is just use the latest version and upgrade regularly. So something new comes, every 3 months or 4 months, you can upgrade. Yeah, some critical security issues might hit you, but while you are in development stage, then that probably wouldn't matter, because they would be discovered before you go live, and you would do a check before you go live. That's one of my favorites. Let's not support save and refresh on our development environments. I agree, using Eclipse, or even IntelliJ, with a web application, for example, or something that requires redeploy on an application server or a servlet container, it's a bit tedious to set up the IDE to be able to just change some piece of code and then switch to the browser or the tool that you're testing your web services with, and it's applied there. It's not immediately obvious option in the IDEs, which is their fault. But yeah, and of course the bonus of having to wait for a redeploy or restart of your application, which when it's small takes 30 seconds, when it gets bigger, 3, 4, 5 minutes maybe. If it's 5 minutes, you probably have a problem with performance, but that's another story. Yeah, in the meantime, you can check Facebook for twice the time that it takes to boot, and then it's already booted. And before you say that I'm a JRebel evangelist, no, I've never used JRebel. I've mostly used hot swap mode of the JVM. You just start your JVM in debug mode, and everything you save goes there. Well, yes, structural changes don't go there. But structural changes, you make them way less often than just changing something. For example, no pointer exception. Why is that? Oh, this here isn't handled. Fix that, retry, OK, now it works. If you didn't have that way of setting up your environment, that would take 10, 15 minutes. And that adds up. So at the end of the day, you have lost a lot of productivity just because you didn't configure your environment to allow you to just save and then refresh. So let's now talk about process a little bit. I won't talk about Agile, of course, but parts of it. So let's skip the code reviews. I've been in a company where we had a policy of code reviews, but it was OK to skip them. So yeah, well, what would happen if we skip a code review? Someone would say, OK, we don't have time. This sprint is very, very tense, so let's skip the code reviews. Or we're really good with that. I don't need code reviews. I mean, my code is perfect, right? And then someone may get offended because we said that, OK, this variable is not properly named. Yeah, it's kind of OK to skip it. We know it's good, but maybe some other time or in some other company. For now, we have a software to write, not to review. And if these points actually are familiar, I almost copy-pasted them to the next slide, which is let's not write tests. And I've been there. It's actually very hard to motivate yourself to write tests because it indeed is time-consuming, and it's not the first thing that naturally comes. You just want to build the thing, to try it, it works, push. On one hand, we don't have time for tests. On the other hand, I'm sure that everyone here has had a bug that he had fixed for at least 3 times, and then it again recurred. And tests are not eliminating these things, but they're putting it to a minimum. So for example, in the last year and a half, I can probably count the serious bugs that we had in our system on my fingers. We have a pretty good coverage, but of course, writing tests doesn't mean that you should strive for having 100% coverage. That is a bit too much. So yeah, don't assume that you're too good. Tests are there to let you not only eliminate these recurring bugs, but also to allow you to refactor. Because refactoring without tests is a bit tricky. You probably know the story of that thing. That was Jesus that someone tried to recreate without knowledge of how to do it exactly. So that's what happened. So the thing that I mentioned in the beginning, let's make it work for the demo. Yeah, we all probably use Agile. We all probably have demos every 2 weeks or so. And just focusing on demo doesn't mean if you do things just for the demo, then it might mean that you don't deliver working features. I've seen that. We have a demo, we have to show it to some stakeholders that don't actually care what they see, because they see tens of demos every week, so they don't remember. But anyway, we're going to make that look like it works, even though it doesn't. And it's fine to show incomplete features. That's probably the only thing that an Agile coach that we had that was really useful, and I remembered from his sessions. It's okay to demo some incomplete features, some islands of functionality that are kind of working or that have a lot of mocks, or not a lot, but some mocks behind. But it's not fine to write crappy code in the code base just to tie some pieces and make it work for a demo, and then forget to clean that up, and then that accumulates a lot. Okay, and speaking of management, that has happened. Let's allow management decisions to influence the software design. There are some technical managers, of course, but non-technical managers are okay to tell us which database to use, which frameworks, which versions of the frameworks, how should we organize our deployments, because they know, and that 89% of test coverage is not enough. Well, I can tell you it is. The thing is, I've had managers call me on the phone and say, okay, we should choose that software. And fortunately, they had a little bit of respect for my opinion. So when I said, okay, we don't need that, they said, okay, we won't use it. But some of them are probably more confident in their knowledge, or whatever you call that, and they would impose such a thing. And that's obviously a no-go. So let's talk about architecture a little bit. Let's use SOAP. I know enterprise Java development is all about SOAP. I have used SOAP for the e-government projects, and it had a lot of encryption and digital signatures and everything like that, and it's complicated. But there you understand why it's there, because everything should be signed, encrypted, and you have a legal responsibility for that. But for most of the software, okay, not most, but for a big percentage of the software, there's no reason to use all that complicated thing. Yeah, we have libraries that can help us handle the serialization, deserialization, the SOAP messages, headers, bodies, etc. But what for? Why wouldn't a simple REST service do, for example? You can still protect it with credentials. You can still serialize to XML or JSON, whatever format you like. And what if we don't actually need web services at all? But that's another question for our next slide. So yeah, if the architect says, okay, let's go for SOAP, then the obvious answer for that would be why? What the requirements that we have that require SOAP? Or let's use an ESB. Because yeah, ESBs have their application, they're there for a reason, and that's when you have multiple systems that you want to integrate, and you don't have control over many of them, and that's fine in a big enterprise structure where software vendors for multiple systems, yeah, things are big and complicated. It's questionable whether it works in that scenario as well, but let's assume it does. But how many projects have you worked on that required that kind of complexity and that you had to integrate so many systems out of your control? Probably few. And again, I've had managers that suggested, okay, let's use an ESB for our system. And it was a website. I mean, why? Just to pour a ton of configuration there and then wonder why it doesn't work and chase bugs for days? No. And yeah, it will break, yeah, for sure. One of my favorite topics is let's use an MQ. I have used an MQ, and I'm currently using an MQ, and I'm using it for a very good reason, because it gives us something that almost nothing else can do. But I've seen projects where MQs are installed and set up and managed for just no apparent reason. Yeah, they give you all of these good benefits that I've listed, decoupling, throughput, fault tolerance, other marketing stuff. And it turns out that you don't actually need these. For most of your functionality, you can probably go, even if some async processing is required, so something that gets queued somewhere and then someone processes that, you're probably fine with just an in-memory queue that some schedule drop or even, for example, Spring has the async annotation that handles that automatically, and you don't need a message queue. Oh, if you do, then of course use a message queue. But the legitimate use cases for a message queue, in my view, are very limited. And all that asynchronous communication, be it a message queue or, for example, a Node.js style programming, where you push something somewhere and then expect a message somewhere else in the listener, that makes code rather unreadable. So when you have a big system, you want to analyze what is the program flow. And having messages passed around makes it rather hard to trace the program flow. If it's one message going there and getting consumed, okay. But then logic gets complicated, things get branched, and you're lost. And yeah, even if a message queue gives you a high throughput or allows you to have spikes, so a lot of users come to your website overnight, and you have to handle somehow the requests, so you put them in the message queue and then process them in the background. Cool. That's a valid use case for message queues sometimes. But do you really need to put your code, to structure your code in a way that it's less readable? Because hardware is cheap. I mean, firing up another instance on Amazon AWS costs a tiny amount of money compared to your salary even. But unreadable code, or code that is hard to trace and analyze, costs more. I cannot tell you how much it costs, because I don't have an cost analysis of the unreadable code, but it does cost. That's another thing that I thought that it's kind of obvious thing not to do. But when you have an application layer, let's call it that way, where all of your business logic takes place, and if you put some instance state in it, that makes it probably impossible or very hard to distribute horizontally. And yeah, it's fine. If you don't plan on having that many users, if it's an internal system, something like that, then it's okay. You can run that on a single very big machine or instance, and it would work. But if for any reason you might want to scale out, having state in your business code, instance state, I mean, that makes it almost impossible to distribute. Of course, caches are an exception to that, because caches are sort of state in your business code, but they're easily dismissible. So even if the cache dies, you can then rebuild it, and that's fine. And the other thing, I've heard that, I've seen that actually. I was even explaining today. let's split the system and make it separately deployable submodules that can go on different machines that we can bring down independently and then deploy. And I've been to a couple of microservices talks as well. It all sounds very good, actually. And yeah, let's make all these modules, of course, communicate through web services, as I mentioned earlier. SOAP, maybe, because, yeah. And when I joined the project in the previous company, they had that. They had a couple of separate modules that actually should be separate. There were some client-facing modules, some internal user-facing module. That's fine. They can be separate because they don't communicate with each other. But we also had a module that was used in front of the search engine, which was Solr. So we had Solr separately deployed, we had a module separately deployed, and then other modules that communicated with the first separately deployed module, which then went to Solr. And why is that? We don't know. What I did, got that, extracted it into a jar, into a dependency, put that into all of the modules, imported it, made it a bit monolithic, of course. You got a bigger class path. And performance was improved, of course, because you don't have the round trips, you don't have the serialization and deserialization. And complexity also dropped because you didn't have to support yet another system. And that didn't seem kind of obvious then. I mean, people did the architecture, and it sounded okay to have it split like that with no actual benefit for it. And splitting an application is perfectly fine. We'll see on the next slide a nice thought by Martin Fowler. But having a monolithic application that is just in the class path, on a single class path that can be deployed on multiple machines. And yeah, you cannot replace your running subsystem while the other systems are okay. But in many cases, these systems are so interdependent that they cannot work without each other anyway. And even if they could, I think the focus should be more on having zero downtime deployments, like rolling updates on your system, using, for example, something like a blue-green deployment, where you have one system, then have a spare set of machines, then you push the changes there, and then you swap DNS, for example. That's the thing I think we should focus more on, rather than splitting our business logic in multiple pieces, just in order to be able to update some parts without updating others. If you can update everything without downtime, then why go the extra mile and scatter your code around? And yeah, monolithic applications work just fine. It, of course, depends on the complexity, and that's what Martin Fowler said in his recent blog post, actually. This is the chart of when a monolithic application is fine and when this splitting or microservices. Microservices is a little bit than just splitting it, but yeah, we won't go into details. I think there is another talk about that. So productivity is the thing that you're aiming for here on this chart. And for small complexity, for smaller applications, you're losing productivity and you're losing time if you go to microservices immediately. If you go to a monolithic application, of course, you're gaining time, but then some architect might say, okay, then in a year, our application will grow more complex, so let's do that in advance and split it so that we can handle everything later. Well, splitting a monolithic application later and refactoring all the things isn't, I think, such a big endeavor, such a hard thing to do. If you have a small application, when at the moment you realize, okay, well, now we're going big, and now is the moment to use actually microservices, I think refactoring that into multiple modules will take you a week or something like that. And that, of course, would happen if you have tests. So if you don't have tests, then probably you refactor and everything will break. But yeah. So let's do all of these things. And I think that was a list of things that define what common sense isn't. So it isn't splitting things without caring whether you need it or not. Common sense isn't letting your manager decide what technologies that you should use. Common sense isn't writing an API that you'd never planned for anyone to use. But as I said, common sense is hard to define, and I hope that defining but what it isn't at least show the part of the picture. But there's a point there, actually, that in these slides, there were some contradictions. Like, reuse existing solutions, I said, like, for example, don't homegrow a framework. And then a couple of slides later, I said, you probably don't need an ESB or a message queue or something like that. Or I said, don't over-design in advance, like don't split your application, but also design good APIs in advance so that everyone can use them. So, yeah, that's the whole thing about common sense. It's not a set of rules that you take from slides and you apply to your software. So if anyone just has learned in his long years of reading blogs and listening to presentations, if you have learned that something is done that way and something is done that way, this is not it is not hard truth. The point is you should think for every particular use case what is applicable here. And I know that is obvious. I mean, I was speaking obvious things for a whole 30-something minutes already, and I know it's obvious. All of these things sounded like, okay, well, of course you should test, and yeah, of course you should check your APIs. But for example, the code that from the Java library itself for XML parsing, it was bad. The Java util date object is there and it's bad. And I've given real-world examples from things that I've seen that are bad, even though all these things sound obvious. And it's hard to actually apply a set of rules to a specific situation. So for every situation, I think that's the sort of the moral of everything. For every situation, don't assume you know the answer. You don't know the answer. You have some experience that hints towards an answer that's probably the right one, but you should verify that. You should question your own experience, if you like, to see if it's really common sense in this particular case, or if it's not. So you have done Node.js applications in the past 2 years, and then because they were high-speed trading applications and you really needed some high throughput, whether that's correct, I don't know. But yeah, we assume that these async applications are faster and have higher throughput and less latency. And then you get a website. And yeah, let's try that in Node.js. Why? Because your code will look horribly. It has nested blocks that are very hard to trace. And yeah, it's JavaScript, so it's horrible by definition. But even that there are Java and Scala libraries for that. Some of them have a pretty good programming model that's easy to read, like Akka, for example. But there are some frameworks that are Node.js-like, so you nest callbacks, and it's hard to read. And if you have 3 or 4 years of experience with a Node.js-like async system, and then you go to a project that obviously looked from a side looks like it doesn't need one, but you apply your experience and your knowledge to that and say, okay, we can do that easily. We'll let you Node.js. And I've always tried to avoid having a checklist of things that I should do on a project or not do on a project. Of course, experience is something that you should definitely take into account, and that's actually where common sense comes from. Common sense comes from experience, but not only. Experience can kind of shade your thoughts on common sense and lure you into thinking that, okay, I now know too much, that's the right thing. No, it's not. It might be, but do question all of your decisions and benchmark what technologies you use. do a proof of concept of alternatives, learn new technologies as you go, because yeah, that salary won't be paying itself in 5 years when the technologies that we use today are already outdated. So yeah, that's kind of the moral of the whole talk, which is about to finish very soon, is that it's not a set of rules and slides and checklists and stuff. It's just trying to see, for this particular use case, with the information that I have, which might be limited, but anyway, try to figure out the best solution and not base it on what someone suggested or even what you have done. Thank you. No questions? One question? Microphone?
Thank you. How you decide what is hype and what is actually a good new technology? Because in our world, all the time there are new awesome things to use. And I've attended presentations where first the person says, use BDD, for example, then a year and a half after, never use BDD again, or something like this. How you judge what is a good hype and what not?
Yeah, it's hard, of course, but when it comes to technologies and frameworks, for example, it's a bit easier. When it comes to processes like BDD, for example, that maybe it's harder to judge. But with technologies, you do proof of concept. I've done that. We have looked into frameworks that are new out there, or even not that new, just popular, and many people are using them. And then you do a simple proof of concept. Okay, let's try to do an application with that. Let's set it up with Maven and Eclipse, and try to do not a hello world, but something that goes to a database and goes back. And then it turns out that, okay, but the Maven integration is not actually quite good. You have to do some really ugly hacks to get it working with Maven. And then again, to get it working with Maven and Eclipse, it's even harder. So probably no one used it together with your setup, which you think is not that uncommon, but it turns out it is. And everyone was actually using it for very simple things, and you're using it for more complex things. So yeah, the general approach is to just do a proof of concept, check the API, see if they have actually the functionality that you need. If they don't, whether there's an alternative or there's an easy way to extend it.
Thank you.
Okay, so the question is, you start a new project, for example, and you choose a set of technologies, and you're not completely sure. Where do you get advices, or do you block, or do you ask in Twitter, or some best practices when you're in doubt?
Yeah, when you start new projects, of course, the first thing you can do is base it on your experience, as I said. So I've used Spring MVC for the, well, not for the past year, but before that for 5 years. So every new project that I start, I'll probably prefer Spring MVC. Then comes the questioning part. So, okay, is Spring MVC really applicable to this use case? The second question, is everyone in the team familiar with this technology, and is it not? So if it isn't, and I'm the only one knowing Spring MVC, and everyone else, for example, knows Wicked, then that's the thing to use. So it's about multiple things: what you know, what the team knows, and what is applicable to the domain, to the use case. No one else? Okay, thank you then.